Hey everyone, welcome to the last video. Not the last video, the last paragraph. I'm going to do a separate video of theory B of this paragraph. But we are going to take a look at the last chapter. Well, we first have taken a look at enlargements with dimensions, lengths and widths. We have taken a look at enlargements in areas. Then maybe it won't surprise you that the last paragraph will be about enlargements and volumes. And they start with an example like this again. They start with a cuboid and we have an enlargement, the image that is a new cuboid. How many times does this cuboid now fit into that cuboid? Well, you can see it to the right. It fits 1, 2, 3, 4, 5, 6, 7, 8 times. Well, they state that the scale factor is 2. So all my lines become 2 times as big. All my areas, you can see that in the front here. Here I start with one rectangle and the area becomes 4 times as big, 2 times 2. Or we set k squared. The volume always becomes k to the 3rd times as big. 2 times 2 times 2 in this case. So if a volume becomes 5 to the 3rd power larger when the scale factor is 5, and the volume becomes 0.6 to the 3rd larger when the scale factor is 0.6, and this applies to all 3D shapes, we can now say if we have a scale factor of k, that means that the volume will become k to the 3rd power times as large. And areas became k squared times as large. Right, so this is an overview. Distances, lengths and widths and such, lines becomes k times as big, areas become k squared as big, volumes become k to the 3rd times as big. Let's take a look. Look at the bamboo lights A, B and C. Bamboo light B, this one, has a volume of 600 cubic centimeters, a height of 25 centimeters, and triangular sides of 150 square centimeter each. So we know the lengths, or we know a length, we know an area, and we know a volume of B. Bamboo light C is an enlargement of B with a scale factor of 1.6. Light A is an enlargement of B with a scale factor of 0.7. That's correct. The scale factor is lower than 1, it's between 0 and 1. That means I get an enlargement that is smaller, right? So this is an image of B and this is an image of B. Calculate the volume in squared centimeters of light C. Well, remember, they're talking about volumes. If we're talking about volumes, we're talking about k to the 3rd power. If I know what k to the 3rd power is, and I do it times the original volume, then I find the new volume. Do I know the volume already? I do, right? The volume is given 600 cubic centimeters for this one. Do I know k to the 3rd power? No, I do not know k to the 3rd power yet, but I do know what k is. The enlargement has a scale factor of 1.6. So we now know that light B is the object what I start with, and C is the image. K is given, it's 1.6. Then k to the 3rd, is 1.6 to the 3rd power times the volume that I start with. And so, in this way, I find the new volume of the image C. Calculate the height, area of one of the triangular sides and the volume of light A. Well, we don't know any dimensions of A, no height, no area, etc. But we do know all those things of B. And we know the scale factor from B to A, it's 0.7. So for example, the height, which was 25, in the object becomes 25 times k. And k was 0.7. So the height becomes 0.7 times 25. The area becomes k squared as big. The area was 150 squared centimeters, so it becomes 150 times 0.7 squared. And then the volume becomes, just as with A, the k to the power of 3 times as big. So 0.7 to the third power times 600, that's what I start with would be, gives me 205.8. So be on the lookout for what they ask you to calculate. What is the object? What is the image? Do I know k? And if I do not know k, is there a way that I can calculate k? For example, by taking a look at the dimension in C and a dimension in B. Remember, that is the formula from 8.3. K is equal to a distance in the image divided by the corresponding distance in the object. And in theory B, we will find a new way to sometimes find the scale factor as well. Practice this, watch new videos if you find stuff difficult, and I will see you in the last explanation video of 8.5b.